Alright, lesson 6.3 is on integration by parts. I'm going to show you how the integration parts formula is derived right now. So first of all, we know from earlier in the year, we know the product rule for differentiation. So if we're going to do the product rule, let's say we're going to do the derivative with respect to x of some expression u times some expression v. So the product rule says you take the first expression times the derivative of the second, plus the second expression times the derivative of the first. So I'm going to write it like this. I'm going to take u times the derivative of v, which I'm going to write as dv over dx, because we're doing the derivative with respect to x, plus, and then v times the derivative of u. So v times the derivative of u with respect to x. So that's one way we could write out the product rule. Next, what we'll do is we'll take the integral of each piece. And by doing that, we could simplify. The integral of the derivative of u times v would just be u times v equals the integral of u. And what we're going to do is write this in a little bit notation. Instead of putting dv over dx, let's just call the derivative of the dv. Okay, make it in differential notation. It's a little bit simpler. We know we're differentiating with respect to x each time. Same thing here. Instead of writing du over dx, let's just call that du, a little bit shorter notation. Now, what we're going to do is subtract the integral of v times du off both sides of the equation. So these would cancel. So what you would have is u times v minus the integral of v times du equals the integral of u dv. Now we're just going to switch the left and right sides around. So it looks like this. This is the formula you're going to use every time that you do integration by parts. The integral of some expression u times dv equals u times v minus the integral of v du. That's the formula for integration by parts. It's derived just by starting with the product rule and integrating each piece and rearranging some terms, and that's what we come up with.